Chapter 5.1 Basic Concepts of Probability Distributions. We'll build intuition with clear examples and pictures. Our goals: 1. Understand what a random variable is. 2. Know the 3 requirements of a valid probability distribution. 3. Visualize a probability histogram. 4. Compute the mean, variance, and standard deviation for a discrete distribution. First, a random variable. It's a rule that assigns a single number to each outcome of a chance process. Let's model 2 births. We'll call X the number of females among 2 babies. The possible values for X are 0, 1, or 2. Since each of the 4 outcomes is equally likely, we can count the number of females in each. That gives a distribution for X: 0 with probability 1/4, 1 with probability 1/2, and 2 with probability 1/4. For a valid probability distribution, we need 3 things. 1. X must be numerical. 2. The probabilities add to 1. 3. Each probability is between 0 and 1 inclusive. Here are 2 quick non-examples. First, categories like red, blue, and green are not a numerical X, so that fails requirement 1. Second, if the probabilities add to more than 1, say 1.3, that fails requirement 2. A probability histogram is just like a relative frequency histogram, but the vertical axis shows probabilities instead of sample fractions. Let's draw the histogram for X equals 0, 1, 2 with those probabilities. These numbers come from the binomial formula. P of X equals the combination of n choose X times P to the X times 1 minus P to the n minus X. For 2 trials, and P equals 0.5, we get 1/4, 1/2, and 1/4. Because a probability distribution describes a whole population of outcomes, its mean and spread are called parameters. For a discrete distribution, the mean mu is the sum of X times P of X. The variance sigma squared equals the sum of X squared times P of X minus mu squared. The standard deviation sigma is the square root of the variance. Let's compute these for our 2 births example. The mean is 0 times 0.25 plus 1 times 0.50 plus 2 times 0.25, which equals 1. The sum of X squared times P of X is 0 plus 1 times 0.50 plus 4 times 0.25, which is 1.5. So the variance equals 1.5 minus 1 squared, which is 0.5. The standard deviation is the square root of 0.5, about 0.71. A quick significance yardstick is the range rule of thumb. Values at or below mu minus 2 sigma are significantly low. Values at or above mu plus 2 sigma are significantly high. With mu equal 1 and sigma about 0.7, mu plus 2 sigma is about 2.4. So X equals 2 is not significantly high. On the histogram, we can also mark the center at 1 and the high threshold near 2.4. The bar at 2 sits below that threshold, matching our conclusion. To summarize, a random variable assigns numbers to outcomes. A valid probability distribution uses numerical X, sums to 1, and keeps each probability between 0 and 1. Probability histograms help us see the shape, and the mean, variance, and standard deviation quantify the center and spread. Great work exploring the core ideas of probability distributions.